Hey everyone, how goes it? And welcome back to Computer Science 145. Today, we're going to talk more about branching statements. Some statements can be nested within the body of another statement. Nested if statements are simply if statements within the body of another if statement. Now, the same is also true with if statements inside of else statements. However, else statements still must have a corresponding if for it to work. Using nested if statements is very useful when testing a combination of conditions. So we can see the syntax over here where we simply have an if statement in the body of another if statement. And remember once again, whenever we're corresponding the body of something, it is what is in between these curly braces. Now we can also see this example below. So if we have these values a, b, and c, and the first one is if a is equal to b, then the first statement is system.out.println a is equal to b. Then we have a nested if and else inside the body of that first if. So if b is equal to c, then we print out b is equal to c. However, if that's not true, the else statement runs, which says b is not equal to c. Looking at this another way, we can diagram nested if and else statements just like this. One major piece of advice that I can give, when in doubt, draw it out. If you're having logic errors in your program, sometimes it's a good idea to diagram this using a flowchart. So for instance, if we enter the program here, we first run this first Boolean expression that corresponds to the same one over here. Now, if this is true, then we move inside the body of this if statement, and then we can check this second Boolean expression. Now, if this is true, and also this is true, then we run the body of this nested if. Now, if this is true, but the second Boolean expression is false, then we run the body of the nested else statement. And also, if this Boolean expression is initially false, well then we just skip over everything. Now in addition to this, you can omit the curly braces whenever an if statement or an else statement has exactly one statement in its body. Now the weird thing about this is an if-else is actually considered to be one statement in Java. Now, in a previous lecture, I highly recommended that we always put the curly braces to indicate the body of something, the body of an if, the body of an else. And the main reason for this is it could cause some major logic errors if you're not absolutely careful. If we look over here, there's two examples. And actually, it has different logic. This example right here is not quite this example. It's true that we could omit the curly braces for this one, as there's only one statement that corresponds to this if, there's only one statement corresponding to this else. But look down here. We would assume that these would be equal, but actually, it's this. An if-else is considered to be one statement. So this entire thing is the statement that's inside the body of this if statement. This can be a very common logic error. So at this stage, go ahead and put the curly braces to clearly define what is the body of an if, what is the body of the else, so we can avoid these types of logic bugs. Now as programmers, we are not lazy, we're efficient. In a lot of cases, we write shorthands in order to speed up development. Another one of those shorthands is called the else-if statement. Essentially, the else-if statement is a shorthand for an if statement in the body of an else statement that corresponds to another if. Much like an else-if statement requires first an if statement. you can have multiple else-if statements in succession. Now always keep in mind, an else-if is a shorthand, so it's the if statement in the else of another if. In order for these statements to run, the previous if or else-if statements must be false. Else-ifs should only be used when conditions depend on a previous condition. In some cases, it might be more appropriate to have multiple if statements in a row instead of if and else-ifs in a row. Now we can see the example syntax right here, and an else-if simply looks like an if statement because it does have the Boolean expression as part of its argument, but it just begins with an else. Now the flowchart for an else-if statement looks like this. So if this Boolean expression, this first one, is true, then we run the body of the if statement only, and then it returns. The only way for an else-if to be considered is the preceding if or else-if has to be false. So if this first Boolean expression is false, then we check the second Boolean expression. Now if that's true, then we run the body of the else-if. Otherwise, we run the body of the else. Using else-ifs can cause major logic errors. So what we see here are two examples that have the exact same logic. So notice this. We have this if statement with this first Boolean expression and a statement inside of here. Then we have an else-if with a Boolean expression 2, a second statement, an else-if with Boolean expression 3 with a third statement, and finally the else has some sort of default statement. Now, as indicated before, an else-if is an if statement inside the body of an else statement that corresponds to an if. So just like the previous if and else, if this is true, we ignore everything inside of this else. Now, if this is false, then we go inside the else and then check this next if statement. Now, what we must keep in mind is the two examples here are not equivalent. If this Boolean expression is true, then we run this statement and immediately jump out. However, let's look over here. If this first Boolean expression is true, well, then we check the next Boolean expression. This if statement is not inside the else of this if. These are independent checks, all three of these. This else only corresponds to this if statement, only. Else if statements are a shorthand, and it makes our code look a little cleaner, but we must understand the logic. That way we don't accidentally introduce these errors. You should only use else if statements if they are dependent on the previous Boolean expression. If that is false, then we need to check the next one. However, if the Boolean expressions are independent of one another, then we need to use if statements instead. Now that we've explained all of that, let's play a game. So live from Columbia, South Carolina, let's make a decision! Yay! Okay, all right. So let me introduce this game. First of all, we have two contestants. Contestant number 1 and contestant number 2. Now first, I'm going to give contestant number 1 a choice. They can either choose box number 1, box number 2, or box number 3. What do you think contestant number 1 should pick? Really, that one? Okay, well, let's see. Contestant number 1, what box do you choose? Okay, box number 2. Now, out of the 2 remaining boxes, contestant number 2, which one will you pick? Contestant number 2 has selected box number 1. Now, let's see what each one of the contestants have won. Let's reveal what's inside box number 2. It's a floppy disk. Well, it seems like contestant number 1 is very happy with this, so that's excellent. All right, now contestant number 2, let's see what was in box number 1. Oh no, a copy of E.T. for the Atari 2600, regarded by a lot of people as one of the worst video games of all time. Now let's see what was in box number 3. A new CPU. It's too bad that neither contestant chose that one, but in either case, thank you both for playing. Now that we've seen that game example, let's do the exact same thing, but inside of code. Now, as you can see here, we have already set up the project, and we've also created the class that we're going to be writing this in. Now, the first thing I'm going to do is we have to have some sort of input. As we noticed before, the two contestants got to make a decision, so we need to get some input from somewhere. And once again, we're going to get that from the console. In order to do that, we need to first import java.util.scanner. That way we can use the type scanner and then create a scanner keyboard equals new scanner system.in. Now we have this type scanner that we called keyboard that's going to scan our system.in, in other words, our console. Now from here, we need to set up some variables. And let's think about this for a second. We had two contestants, contestant 1 and 2. They need to be able to contain their prize. So let's go ahead and initially create some variables with what they started with. We first must declare the variable, so what type should we use? I'm going to assume that we're going to use a string. So first thing I'm going to create is a string C1 prize, contestant 1 prize, and let's just go ahead and assign this to the string nothing. They came into this game with nothing. They may leave this game with nothing. Let's do the exact same thing for contestant number 2. String C2 prize is equal to nothing. Now from there, they had to choose what was inside of these boxes. For argument's sake, what was inside those boxes doesn't change. So I would argue that we should make these into constants. In order to do that, I'm going to go ahead and go outside the main method and define 3 constant values. Public static final string box 1, and box 1 contained ET for the Atari 2600. Now let's create another one. Public static final string box 2. Now this one had a floppy disk. And the final one, public static final string box 3, had a brand new CPU. Now that we've set up these variables, we need to go ahead and prompt the user, in other words, prompt the contestant. System.out.println. Let's make a decision. Let's go ahead and throw an inline, just so it formats it nicely. From there, let's say this. Contestant 1, will you choose box 1, box 2, or box 3? Now we used the slash quote in order to literally put the quotes in there. That way, when people are playing this, they know that we want literally box 1, box 2, or box number 3. So now we need to store their answer somewhere, and since we're using strings, let's assume that we're going to use a string again. String answer is equal to, now we need to capture that input from the console. So let's use keyboard.nextLine. Now based on their answer, we need to be able to make some decisions. So let's just assume that contestant 1 actually chose box number 1 first. We need to check for that, and whenever we need to make a decision, we need to utilize an if statement. So if, inside the arguments, in other words, inside of the parenthesis of this if statement, we need to put some sort of Boolean expression. In other words, something that gives us a true and a false value. One thing that we have to remember, whenever we are using strings, these are class types. When you're checking the contents of a class type, when you're checking the contents of a string, what we need to do is utilize the method equals in order to check its contents. So I'm going to use the string answer, and I'm going to then call the method equals ignore case. And then inside of these arguments, I'm going to say box 1. So now, if contestant number 1 chose box number 1, then let's go ahead and assign what is stored inside of here, inside of the contestant 1 prize. C1 prize is now assigned to box 1. Oh, but hold on, I just noticed something. I didn't follow the standard format for writing constants. I'm going to go ahead and edit this. Going back to box 1, box 2, and box 3, it's strongly advised that you all capitalize every character in constants. That way, we know they're constants. Now notice, this caused a syntax error right here, because once again, Java is case sensitive. This would be considered a different variable identifier from that. So we need to make sure this matches that. Now effectively, what we have done is given contestant number 1 what was found inside this box. Now after this, we need to go ahead and prompt the second contestant to choose box number 2 or 3. So system.out.println, contestant 2, will you choose box 2 or box 3? Now, just like contestant number 1, we need to basically get their input. Well, here's the thing. We could either create a brand new variable that's a string, or in this case, we can reuse what we have here. Contestant number 1 has already answered. So let's go ahead and use this again for contestant 2. Answer is assigned to keyboard.nextLine. Now, inside of this if statement, we're going to write some nested if statements. So now, contestant number 2, if their answer dot equals ignore case, box 2. Then inside of here, we assign C2 prize is equal to box 2. However, maybe contestant number 2 didn't choose box number 2. They chose box number 3. It feels like that decision is based on this one being false. They can't choose both, so they have to choose one or the other. So if this is false, then we have to go to an else. But we have to check if this answer dot equals ignore case, box 3. Now, what we're going to do is assign contestant 2 prize is equal to what's found in box number 3. Now, we're almost done, but there might be a case that has not even been considered. What if contestant number 2 didn't choose either? They didn't pick box 2 or box 3. So in other words, If this is false and this is false, then by default, we land into this else. So if they didn't choose box 2 or box 3, so they just gave us an invalid input, well, it's system.out.println. That's not valid. You get nothing. And as we can see, we didn't assign anything to contestant number 2 prize, so they left with nothing. So now, inside of the body of this if statement, we had an if, an else if, and an else to take care of every other decision that contestant 2 could have chosen. So now we can see that the body of this if statement contains everything if contestant number 1 chose box number 1. However, in our example, they did not choose box number 1, they chose box number 2. In that case, what we need to do is account for that decision as well. Now, just like inside of here, we used an else if because contestant number 1 could only choose box 2 or box number 3. They couldn't choose both. The same thing applies with this one, with contestant number 1. So if they did not choose box number 1, they could have either chosen box 2 or 3. This means this would have to be false. So now, the body of this if statement, we enter down, we create an else if answer dot equals ignore case box 2. So now we have to run a very similar procedure, except we have to account for contestant 1 choosing box number 2. So in this case, we assign the contestant 1 prize is equal to box 2. Now after that, we have to prompt contestant number 2 to either choose box 1 or 3. We then need to receive their input, so answer equals keyboard.nextLine. Now once we have their answer, what we need to do is something similar to here, but in this case, instead of box number 2, it needs to be box number 1. I'm going to quickly just fill this in. Now we can see, if contestant 1 chose box number 2, we ask contestant 2 to choose box 1 or 3. Now if contestant number 2 chose box 1, then we assign the box 1 prize or the box 3 prize, and if they chose neither, they get nothing. But wait, that's not all. Maybe contestant 1 chose box number 3. So now we got to account for every one of those combinations. Now once again, I'm going to very quickly fill this in. So now we have the case, if contestant 1 chose box number 3, we assign box number 3, and then we ask contestant 2 to choose 1 or 2. Then, if they chose 1, assign them box number 1, chose 2, assign box number 2. And if they chose neither, you get nothing. However, we're still not quite done. Because maybe initially, contestant number 1 didn't choose box 1, box 2, or box 3. So else. Now by default, so what we can do is prompt both of them that that's not valid, and maybe both of them get nothing. And in this case, it makes sense to go ahead and stop the entire program. So I'm going to go ahead and call system.exit with a status of 0. And this will immediately halt this program right here. Now assuming that didn't happen, at the very end, what we're going to do is reveal what they won. So we're going to say system.out.println contestant 1 won, and we're going to append C1 prize. Then we're going to do an end line, and then contestant 2 won plus C2 prize. Do another end line. Thank you for playing. Now let's go ahead and try this out to see if it all works. Compiling this and running it. Contestant 1, will he choose box 1, box 2, or box 3? Let's go ahead and play out what happened in our example. So contestant 1 chose box 2. Now it asks, contestant 2, will you choose box 2 or 3? Contestant 2 chose box 1. Contestant 1 won a floppy disk. Contestant 2 won ET for the Atari. And thank you for playing. As you can see, this was a lot of code for us to write for honestly such a very simple game. But we have to take into account every combination that could happen in order for this to work. One other thing I want to show today. Once we get to branching statements in decision making, this can cause a lot of logic errors, which means we need to be able to debug our code to make sure that we don't have these. One piece of advice that I could give is go ahead and use system.out print lines in order to see what's happening inside your code. Now, if you're using a fully functional IDE like Eclipse, you also have things called debugging tools. I'm going to go ahead and show an example of a debugging tool. Now, inside of Eclipse, you can see here there's this little bar that's beside the line numbers. What I'm going to do, beside line number 12, I'm going to double click right here. And if you notice, it puts a tiny little dot right there. In most IDEs, this is called a breakpoint. And what we can do is instead of compiling and running, we can run our code inside a debug mode. We can see that right here. It's the little bug. When we do that, whenever the code reaches a breakpoint, it pauses the program and allows us to look at what's going on in memory and then to also step through our code one line at a time. Clicking the bug, let's see what happens. Now, in a lot of cases, what it's going to do is ask you to switch perspectives. Go ahead and choose to switch it. Now, this is the debug perspective. If we needed to go back to our Java perspective, it's up here. It's that little J. As you can see, there's a bug, there's a J. So this goes back to this view, this goes to debug view. Now from there, what we can see over here, this is what's inside of our memory. And this is the line that the CPU is about to run. Looking over here, we have a few different options, but what I'm going to do is step over. Now let's keep an eye on the variables. Let's keep an eye on what's going on in memory right here as I step through it. The first thing that happens is we declare a contestant 1 prize and assign it the value nothing. Stepping to the next line, it does the same thing, creates contestant 2 prize, assigns it to nothing. Then we're going to print to the console the thing right here. Then when we step forward, what it's doing is waiting for us to enter our answer. So I'm going to type in box 1 and then press enter. Now let's look what's happening in memory. We have declared this variable answer and assign it exactly what I typed in here, box 1. Scrolling down a little bit. Now, it's going to check whether or not this is true. And let's see what happens. Because I did enter box 1, it's going to go inside the body of this if statement. And then, contestant 1 prize gets assigned to what was inside of box number 1. Then it prompts contestant 2. And now it's going to wait for an answer. Let's see what happens if we enter box 3. Now this if statement is going to be false because as you can see here, answer now got reassigned to box number 3. Stepping through that, we're going to jump past that if statement and now we're going to check this else if. Going inside the body of this else if, we assign contestant 2 prize to a brand new CPU. And now because that was true, we jump outside of that else if. And also, because this if statement was true, we jump to the end of our program. And finally, as you can see, we print out Contestant 1 won ET for the Atari, Contestant 2 won a brand new CPU, and thank you for playing. Switching back our perspective, the key idea to keep in mind, an else if is an if statement that's in the body of the else part of another if statement. In our example, because this was true, we ran what was inside of this if statement and then immediately jumped outside of it to the end. Now, there's only a few more details that we need to go over. There's a special kind of operator called the conditional operator, otherwise known as the ternary operator or the one-line if statement. So if you see a combination of a question mark and a colon together, it basically creates a one-line if statement. So what you can see here is we can assign the value of a variable to some Boolean expression followed by a question mark. Then, if this is true, we assign value 1. However, if this is false, we assign value 2. Now, these can be very useful for writing print statements. We also introduced this earlier, but if we need to immediately stop a program, we can use the exit method. Now, this can be used whenever an error arises that will prevent a program from working. And more often than not, we use system.exit with the value 0. Now, speaking of operators, we have to understand that there are precedence rules for a lot of the new operators that we have discussed. It's not as simple as just using parenthesis, addition, subtraction, division, and multiplication. It's much more broad in computing. Like for instance, we have a classification of operators called unary. In this case, the plus and the minus mean positive or negative. The other unary operators are plus plus, minus minus, and the not operator. From there, we have binary arithmetic operators, which in this case is multiplication, division, and mod. We also have another classification of binary arithmetic operators that is plus and minus. From there, we have Boolean operators like strictly less than, strictly greater than, less than or equal to, or greater than or equal to. That's followed by equals and not equals. We also have the Boolean operators, but the ones that we really need to keep in mind is the and the or. The and operator takes precedence over the or operator. Java uses what's called short circuit evaluation. So sometimes only part of a Boolean expression needs to be evaluated in order to determine its entire value. Now remember this, if the first operand of an and is false, then the entire expression is false, because the only way for a compound Boolean expression that uses an and to be true is both expressions have to be true. So in other words, if we have this example right here, where we assign Boolean A and B, and A is assigned to false, B is assigned to true, because A is false, we never check B. Now, an alternative example is if we assign A and B true and false. Because A is true and we're using an or, we never have to check B because we already know this compound Boolean expression is going to be true. Understanding this and using this effectively can create very efficient code, and sometimes it becomes absolutely necessary. In this lecture, we have introduced that we can have nested if statements and also introduced a shorthand called an else if, where it is simply an if statement in the body of an else that corresponds to another if statement. With all that being said, I'll see you next time.